welcome, welcome. Thanks for joining us at our December Beyond Our Value webinar. Hey, everybody, welcome. We see some people joining us. We're just going to give it a minute while everybody has a second to log into their computers. While we're waiting, feel free to introduce yourself in the chat. Tell us your name, where you're from, what brings you here today. I'm Alexandra Hodges. I'm the Sales and Marketing Coordinator for TimberHP. I host our monthly webinars, Beyond Our Value. Today, I'm joined by Addie Atkins and Scott Johnston, who are going to lead our presentations. Alex Donnelly, our lead inside sales and technical support, is going to be fielding questions in the background, so you'll see his icon, but probably won't hear his voice today. That being said, this webinar, we like to keep our questions focused in the Q&A box. That helps us monitor questions coming in, whether or not they've been answered. The chat is awesome for giving us little tidbits of information, but if you really feel like you want something answered, go ahead and throw it in the Q&A. Alex will be fielding those. Welcome, welcome. This is, like we mentioned, our final Beyond Our Value of 2023. We have done an amazing series of deep dives into fire and acoustic assemblies. We've done wood fiber competitive advantage, wood fiber 101, solving performance demands. And today as a culmination, we'll be touching upon a little bit of all of those aspects. But I'll save the meat of the presentation for Addie and Scott. Once again, if you do have questions throughout the presentation today, please throw them in the Q&A box. Chat, you can go ahead and introduce yourself, tell us where you're from, what brings you here. And we'll just give it a couple more seconds for folks to join. Once again, I'm Alexandra Hodges, Sales and Marketing Coordinator. Thanks so much for making time with us. I'm going to go ahead and pass it over to Addie Atkins and Scott J. Go for it.
Great. Hodges, are we ready to get started, or are we?
Yeah, I think we are ready to get started.
Okay, great. My name is Addie Atkins. I'm the Territory Sales Manager for Massachusetts and Vermont. I'm going to start the presentation off, and then Scott will jump in midway through. Feel free to shoot questions into the Q&A as we get started. Scott and my contact information is here. You can always call into the 800 number also. But if you want to get in touch with either of us directly, email, call, anytime, we are here to answer your questions. All right, so we are going to start off with kind of the basics. TimberHP, we are the first US manufacturer making wood fiber insulation. We are still getting this process up and running and off the ground, but we do have products in the market right now. So we are selling the timber fill product. You can get that locally in New England and on the, I would say, Mid-Atlantic North. If you're farther outside of that zone, reach out to us, and we do have some capacity to get material to other places, and we will work with you on those situations. We are in the process of bringing the timber bat up. We've got product that's going out for third-party testing, and we're getting ready to launch that commercially in February with the 3.5 and the 5.5 inch products. And then we will roll out the 7.25 in March. Timber board, it will be the next product line that we will focus on after the timber bat gets into the market. We are looking at a July launch for the square edge product. And then after that initial launch, as we dial everything in, we'll add a tongue and groove product, some different sizes of things, but we'll expand on that offering as we grow into 2025. So TimberHP, high performance, healthy planet, healthy people. High performance products are really key in the insulation category. You're talking about the building envelope, you're talking about, helping the thermal performance of the building and being able to solve acoustical challenges in between units and buildings and rooms. So TimberHP wood fiber insulation is going to give you a vapor open assembly, which is going to give you great R value and create a nice stable temperature in your living environment. From a healthy planet side of things, the product is recyclable. It's renewable. We are using waste chips from lumber mills, so we're not cutting any new trees down in order to manufacture our product. It is non-toxic and carbon negative. Carbon negative, really being able to decarbonize our buildings and reduce the overall embodied carbon in the built environment is key. We're seeing more and more architects focus on this moving forward. Healthy people, healthy for the installer who is, blowing it into your attic or dense packing those walls, and healthy for the people that are living in those buildings. So increasing the indoor air quality, having a safe and stable place to live and to work. All right, so as we're introducing wood fiber insulation, this picture, I think, just gives you a little bit of feel for what the bat is going to be like as it comes to market. So it's a semi-rigid bat, easy to handle. This worker's just using his hands. He's not in a full hazmat suit in order to touch it. Just kind of talks to the benefits of the product, the ease of the installation. And what is wood fiber insulation? Well, we're making it in Madison, Maine. So it is a product that is made in the US. It is a carbon storing insulation product. So it is addressing the thermal loss, but then it is also being able to store carbon. We'll get more into that as we get through the presentation, but it's the only insulation product in the market that can do this on a large scale across the country as we grow. High performance, highly recyclable. When you cut it, you're getting sawdust. It's easy to work with, non-toxic, safe, good for your indoor air quality. Class A, Class B flame spread, and we'll get into those, into the different products as we move through the presentation, but it gives you a high degree of fire protection. The picture here on the right is just showing you different places where the product can be applied. You can use the timber fill in the ceilings, a loose fill blown in. You can dense pack it into the wall. You can use bats in the ceilings, bats in the wall cavity, and then the timber board as a continuous exterior layer, above grade insulation product. And this is just kind of a quick look at the manufacturing process. We are using softwood residual chips. So these are wood chips that are a byproduct from the lumber industry. So work with different mills in the area, and they're going to take in this log like you see on the left hand of the screen, and they're going to optimize that log. So they're going to cut as many rectangular boards as they can out of that log. All those little pieces around those rectangles is becomes a chip. It's a waste product at that point. Those chips used to be sold to the paper mills. Some of them still do, but a lot of paper mills have shut down over the years because we don't use as much paper. A lot of our media is driven through electronics. We're reading everything online. We don't buy 5 newspapers every morning. So the demand for those waste chips has been greatly reduced. Most mills, if they don't have somewhere to sell it, they're just burning it off right now and using the energy. So TimberHP is creating another revenue source for these lumber mills to be able to make some money and sell these waste chips to another high performance product. So we're going to buy these wood chips. They're going to be softwood species. And then we take those in, we steam them, kind of soften them up. We macerate them in between plates to create them into small fluffy fibers to be able to use as an insulation product. We put in any additives that we need for the product that we're making at that time. And then it is dried across the plant, kind of fluffed up, packed into cubes if we're making the timber fill, or transformed into a bat if we're making the timber bat or the board that day. So that's kind of a quick glance at the manufacturing. And what makes this product really work in the US and in Maine specifically is that we have a lot of timberland that's available. So we've got a lot of certified either FSC or SFI. Lots of forest managers even go through both systems. But these forests are well managed. They're looked after. They're using them to make dimensional lumber, moldings, a wide variety of different building materials. And, they are clear cutting, they're properly managing, they're supporting this forest products industry. And then we come in, use the waste chips so that we can help them be more profitable and make wood products more viable here in the US. And with using that wood chip and using a waste product, the nice part from our side of things is that we're using that lowest cost material. So, on the East Coast where we have these wood chips readily available, we are using those because it's the right product for manufacturing, but it also allows us to have a very competitively priced product to enter the market with. As we grow, we might look at different resources. We might use treetops and branches and whatever else is the next low cost option. But right now, these wood chips are readily available. We've got plenty that we can choose from. We aren't going to stop producing because we can't get those quick enough at the mill. They're readily available all around us where we are in Madison, Maine. But the nice part about that is we can come to market with competitive pricing. So that's what this slide here is really showing and talking about. The timber fill, you'll see that priced competitively against the current cellulose products in the market. There's a little bit of a range of cellulose products and pricing, but we're going to be right in there competitive with the everyday brands that you see there. When we're talking about the timber board, that'll be the third product to launch, but as a new product, these are our goals. This is where we're looking to come in. We're going to be competitive with the foam products and a little bit less than the mineral wool products. And one other thing just to note, because these are different products, we're going to be competitive with foam on the R value. So maybe not thickness for thickness, because our get a little higher R value out of the foam, but per inch, but we'll be competitive on the R value numbers, which is going to be the most important thing. You just might be building that wall out a little bit wider if you're using the timber board. And with timber bat, again, our goal is to come in right below the mineral wool price point. You're gonna have a lot of the similar performances with that category, but it's not gonna be able to be competitive with fiberglass, which is your low cost leader, not as high performance of a product. But when you're looking at fiberglass, you can roll it up really small and tight and get a lot of that on a truck. So they are still going to be the most competitive product out there on the market price point wise. All right, so now we're going to kind of take a little deeper dive into each of the timber fill, the timber bat, and the timber board, and talk about those a little bit more specifically. The timber fill can be dense packed into the cavity. It can be used between rafters, the joists, or it can be a loose fill kind of blanket insulation. You can see that in the picture on the right where they're just kind of filling from the top. Or if you're dense packing, you're netting, and then you're dense packing into the wall cavity. Composition, like I said, it's going to be softwood fibers, and then these fibers are treated with a boric acid. So one thing that does make us a bit unique is that we apply that boric acid in the wet process. So as it's steamed, macerated, the boric acid is mixed with water and then it's sprayed onto the fiber. That allows it to coat the fibers entirely, and it helps with the overall flame spread rating because that boric acid is very effective at staying adhered to the fibers, and it's not blowing off in the process when when it's coming through the tube and getting sprayed into the attic or into the wall. So that boric acid really holds tight to the fibers. The product is an R 3.8 per inch when it's dense packed. And you can dense pack it at a little bit lower it's about 3 pounds per cubic foot rather than 3.5 to 4 with cellulose. Part of that is this fiber, it's a little tanglier, it's a little bit longer of a fiber, it helps self-support at a little bit lower density. And that's kind of the nature of it because, right, it came from a wood chip. This is the first time it's being manipulated and turned into a new product, where say if you were comparing this to like a cellulose product, newspaper's been recycled, many times those fibers have been broken down and flattened and smushed. So The timber fill is just a little bit more robust of a product, which is going to help it perform well in the wall cavity and self-support. The boric acid, like we were saying, that is what is going to help us get to this Class A flame spread. It resists mold and mildew, and typically when you add borate to different building materials, you'll also see that they will deter insects and rodents. Still, definitely in all of your details, keep anything in there to deter mice and animals from getting in, because they will try to get into anything. But in general, keep those barriers in there. But if they get there, the boric acid is a natural salt. It's going to dehydrate them. They're not going to like being around it. All right, so we really like to burn things and show you what happens and show you the boric acid in full effect here. I'm going to play this video and you'll see what happens when we put a flame and kind of the power of the boric acid and how the timber fill performs. So right here, you've got some timber fill. You've got a penny on top. We're going to put the blowtorch on it here until this penny melts. So it's getting up nice and hot. You can see that the material is starting to catch, but as soon as we pull this flame away, it's going to self-suppress. So that's the boric acid. If we didn't have the boric acid on there, those wood fibers would light up quickly. All right, so we're looking at timber fill and taking a look at the competitive advantages it has against what is in the marketplace right now. The nice part about it is it's a pure, sustainable, consistent feedstock. So when those wood chips come into our manufacturing facility, we're going to scan them for metal and make sure there's not anything else in there. But they are using a waste product in this situation, but it's not a recycled product that goes all the way through the waste stream and comes back. So you don't get plastic cups and plastic bags and other random things that people threw into the recycling by accident instead of the garbage cans. So having this nice, clean, consistent feedstock is just going to mean that you're not taking your machines down, you're not having things that get stuck in there. It's going to limit the damage and the downtime for machines for your installation crews. Talked about the dust a little bit. That fiber, that fire retardant is going to stay locked into those fibers, so it's not going to come off in dust clouds. It's going to make it very effective over time. That robust, little bit bigger fiber is going to help it self-support, and it's going to give you a great install at lower densities. The dense attic blanket reduces your airflow. We will have a very stable product, stable price point for our product as we launch into the market, because we've got a lot of feedstock and we are going to be able to deliver that price point as we build and grow. There's also no inks, no toxins, no other foreign debris, nothing else to worry about. You've got, wood and boric acid in this product, so it's simple and easy to work with. All right, I'm going to show you a video here. Not sure if you can hear the music on this, but so you see how the 25-pound bag goes in, gets broken up by the machine. It's going to filter through the tubes, and then we're dense packing here into the wall. You can do this from the inside, you can do it from the outside if you're doing retrofit work, and you can see how it's self-supporting there. It's simulated in an attic. So just to give you a little bit of a feel for how it works, we've done some extensive testing over the last few months with working with different machines and different blowers and out to different job sites and different crews. So we do have some best practices and some tips and tricks when you're using different machines when you're blowing this in. A double blower or larger is great if you're dense packing the wall. That just gives you a little more oomph to get the correct densities. All right, now we're going to jump into the timber bat insulation. So this product right now we are manufacturing in the plant. Um, I was up there last week. It's really cool to be able to see this coming off the line and the company growing. This is a thermal cavity insulation. It also has great acoustical properties. So interior spaces, demising walls, going to be a great application for this. For the timber bat. Again, the composition, same softwood fibers, it's that same feedstock that's coming in. Although we do have one more component. You've got the boric acid like the fill, but then you need something to hold it all together and create that shape. So the polyamide binding fiber, kind of think of it like a polyester. It looks like a fluffy cotton polyester fiber. It gets broken up and kind of mixed through with the wood fiber and the boric acid. So it's all the way through the product, and that's going to melt to create the cohesion and hold everything together. That melting effect gives it the shape, it gives it the bounce back, it allows it to friction fit into the wall and have a little bit of play so that you can firmly press it in, and then it will have contact on all sides. Sizing wise, we're designing this that will have sizing for wood and non-structural steel framing, 16-inch, 24 on center, and then your 3, 3.5, 5.5, 6, 7.25, like we said in the beginning, is going to launch a little bit later. But those are your traditional insulation sizes. As we grow and develop in the market, if there's other sizes that you need, come back to us, let us know what works best in different markets, and we will see how we can make those work. So a nice thing about timber bat is that it's an R4 per inch, and it's a vapor open system. It's a flexible, semi-rigid. You can kind of see in the pictures on the right here that you can bend it, you can work it. If you've got to run a wire through it, you just peel it open, allows the wire to go through. So it's a very durable, one person can lift it, put it into the wall, friction fit it in. Non-toxic, no harmful fibers, nothing that's off-gassing, nothing to worry about for the installer handling it and putting it into the wall. This product does have the boric acid, so it does still have the Class A flame spread. That also works as the mold and mildew inhibitor, and again, deters pests and insects. Here's more fire. We definitely like to burn things. But as you can see here, again, you're putting the flame right to the bat. It is catching fire, but you really have to sustain the fire on there in order to keep that going. As soon as you pull that flame away, it's going to self-suppress. And as you can see from the outside, it's just kind of charring the outside of the bat. So it's not penetrating all the way through, it's not breaking it down. And that's really that boric acid, which is doing the job there and suppressing that fire. So if you're taking a look at the timber bat, competitive advantages is you've got a high R value per inch with the R4. But the density, you still have the flexibility, you still have the workability. It's going to be rigid enough that you're not going to have to worry about like wind washing, and it's going to prevent over compressing. So you're going to have a nice, easy install for your contractors. No itchy, scratchy fibers to work with. No formaldehyde, which is still in mineral wool. No harmful binders. Industry-leading acoustical performance. We've got acoustical data in our technical resources file online. Feel free to grab that if you need that. That goes through all the assemblies. Has the ability to balance humidity levels in the building due to the hygroscopic nature of wood. Low thermal conductivity and high heat capacity improve the temperature stability in the building. And we'll break those down and show you how that works with some testing as we go through this presentation. Now we'll transition to the third product, the timber board insulation. This product will be the next line that we turn on and commission at the plant. Exterior continuous insulation. Code is driving this in a lot of markets, so it's becoming more and more important. Builders are paying more attention. If they haven't used it before, they know that they need to, or at least need to get up to speed on how to do it correctly. And we'll probably also see this in the interior, basements, walls, floors, ceilings, where we could really use it for the acoustical benefit. Composition of this board is a little bit different. It's the same softwood fibers, but then we use a PMDI adhesive, which is like the adhesive, say, in like an Avantec, and we use a paraffin wax. That's because it's an exterior board, so it's got to be a little bit more durable. It needs to be able to hold up to the weather, and it's got to be able to shed moisture. Sizes on this, we're going to start at a 1-inch thick and go to a 9 1/4. That's a really big board. And then we're going to have some flexibility with the sizes, starting with the 4x8 sheet and then adding, say, a 2x8, 2x4. And that'll give you, a little bit of flexibility when you're getting into those larger panels, ease of install, a little bit less weight if you're using some of the smaller pieces. These products also are going to be vary a little bit in the R value. Really depends on the density of each product. So the R value will shift with the different sizing, but it'll be from a 3.4 to a 3.7 as that rolls off the line. We'll dial all of those things, and that'll be in our details. But the product is hydrophobic and it's vapor open. So it's going to give you superior performance on the exterior of the house. It's got a high compressive strength. That's really key because a lot of the other products in this category do not have that high compressive strength. It's easy to overdrive fasteners. So we're looking at this from the contractor side. How do we make it as easy to install so that someone wants to come back and use the product again? This timber board, when we launch, is going to be a Class B flame spread because it does not have that boric acid in it. That's something that may change in the future. We may look to add that, but I'll show you some fire videos on this too. It's pretty amazing because this board is so dense that it does really well in fire situations also. This first video here, this is just showing you bulk moisture demonstration. So you leave this outside in the rain, this is what happens. It's gonna bead up. It's that wax that's really, coating and protecting those fibers, which is gonna shed the moisture. And just to give you some real life examples, on the left-hand screen here, the College of the Atlantic. This was a project on Mount Desert Island up in Maine. This is actually Gutex, I believe, but that was imported because our board is not available yet. But typical wood construction, you can see the wood fiber board on the exterior strapped then for siding. So just probably, details that you're used to looking at, just with the wood fiber exterior insulation. And just to talk a little more to the durability, you can see at the picture at the top left that the contractors on site there, they just threw it on the ground and used it as stairs. So obviously not OSHA approved, but it talks to the durability. They weren't worried about walking on it. They knew that it would be fine sitting in the sand and the dirt and getting rained on every day. So I think when people see that, they realize that it is rugged. It's not going to crumble. It's not going to fall apart on the first raindrop. We warranty the product with 6 months of exposure on the outside of the building, and then 3 months if the board is on the roof application. So just you're going to get a little bit more rain and UV exposure up on the roof, but 6 months gives you a long time to get siding onto the project. That should be enough time, even with all the crazy delays that go on in the construction industry. So this next video is bringing us back to fire again, just to show you what happens with some of the different foam boards on the outside. We're going to compare this, and I believe, and then you'll see the first 3 are going to crumble quickly. So, I mean, there's toxic things that are being off gas. No firefighter is going to want to be in the middle of that. They melt quickly, they drip, they're pretty gross. And then we get to the timber board. which again is a Class B flame spread, but you can see how well it's doing. It's kind of like trying to burn a giant log. It's like charring on the outside, not penetrating all the way through, not, taking it down quickly, but just kind of slowly trying to gain traction there on like if it was a giant log. But it really comes back to the density of the product, where that gives it the higher performance. All right, so we jump into the timber board competitive advantages. Highly vapor open, preventing issues with trapped humidity. We'll get into that in a little more detail also as we go. The density results in great compressive strength, which makes it easier to install, which is going to be key for your contractors on site. Easy to fasten. As we grow the product line, we'll add the tongue and groove, which will help speed up the install. Single layer insulation up to 9¼ or you can use the smaller sizes and stagger your seams. So it's really whatever you want to do in the field, but you've got those options. Cuts with standard tools, no worries of itchy fibers or, what you're leaving in someone's yard. It's just going to be sawdust on the ground when you walk away. All right, and then I am going to hand things over to Scott Johnston right now, and he's going to jump in for the rest of the presentation.
Thank you, Addie. As always, just a fabulous job. And hopefully our marvels of technology will work here. There we go. Can you hear me okay, Addie?
Yes.
Well, greetings from Madison, Maine. That's where I'm at today, and enjoying a nice winter day. It's 22 degrees and balmy. No snow in the mountains. We did have all that rain, so it took care of that. But that just want to let you know where I'm at. We are producing some products as well. Start my video. I don't know what that was, but all right. I think I'm off now. Let's see. Addie, can you hear me?
Scott, I can see you, but I don't know if you're sharing your screen.
Oh, really?
We're gonna go screen.
You are good to go. Good to go.
Oh,
We can
sorry.
Oh, yes.
You are all set.
Am I? Because it.
Go back to your current slide. Yeah, there you go.
Yeah, there was some funky things going on there, Hutch. All right, we're back up. Can you hear me? All right, great. This is what we want to avoid, obviously. As the image in the upper right, this woman is not exactly happy finding the mold in the house. And this is really what we talk about with vapor open assemblies, with the benefits of the wood fiber, as Addie spoke to on the previous slides. We are looking at code to drive us in terms of our selections for our exterior building enclosures. And some people have been, following code and using some products that have zero permeance, and that's fine as long as they're following the prescription in terms of getting the right R value for both the inside cavity as well as the exterior. But if they're not following code, or if by chance they missed the memo on the fact that if it's drying to the interior of the home that you do not want to put a zero perm up against the studs like the old days, there is a potential for obviously having the dew point on that back of the OSB during winter conditions. So we always talk about reducing risk. And so, looking at either the timber fill or the timber bat in the inside cavity coupled with our timber board, that mitigates the risk for some of that concerns that one might have during a very, very, very cold winter and or a catastrophic leakage in a window assembly or MEP where there's some serious bulk water getting into that assembly. So when we look at that vapor open assembly, I think this slide does a really nice job. But before I get into the animated detail on the right, which is hard for many of us to not look at because it's animated, I just want to mention the fact that, depending upon the product line that you're working with, we have a 40 to 70 perm, which is really fantastic in those situations, whether it's high humidity or some trace elements of a roof or a cladding scenario where there's some small leakage or bulk leakage coming into that opening. Now, if we have high humidity, or if for some reason there's a breach in the cladding and we've got a failure, the product can actually still perform to its posted R value, even with 15% of moisture weight, if you will, being put into the product. Now, obviously, we want to make sure if there's something that's creating water leakage and the product's not able to dry out, just like with any wood frame construction, we need products in the assembly to dry out. We want to rectify the damage. But the good news is, because of the durability of the product, if we do find that breach, and if the product insulation hasn't been sitting in a moist or very damp condition for some time, the product will very easily dry out and still perform. Obviously the only challenge would be is if it was something catastrophic where you'd want to replace that. But on the right, what we're really showing is this. You have your gypsum on the inside to the left, and then in the middle, the white detail there is going to be what you're picking for your sheathing. What's your shear strength? Do I like OSB? Do I like plywood? And then you're really going to just continue to use what you've done in the past in terms of your weather resistant barrier. So for bulk water, for air, what you are comfortable with is what you're going to continue to use. There was a question that came up about structural. None of these products that we're offering today are structural. They're purely either for acoustic and or for thermal. So we do still want to depend upon that framing as well as the sheathing that you choose to be addressing the shear and the weather resistant barrier, air and water. But what's nice about this is, to the exterior of the building, you basically in essence have a Gore-Tex running suit. So you have the ability to, if you're out in the rain, have that water beat off that, in this case, timber board, but yet it's vapor open, as we said, depending upon the dimension, 30 to 70 perms. If we had some significant concerns in that wall cavity and the conditions were right from a physics standpoint, you'd have some drying condition going through that OSB or the plywood, totally dependent upon that permeance. Commodity OSB might be a 6-7, a high premium OSB might be a 2 perm because of the MDI resin and such, and plywood would be a little bit more aggressive. Eventually that water would work its way out, and because there's permeance through that panel that we have, the timber board, it would come out through that assembly as well. So whether it's high moisture content or some type of failure in the building, it really allows that assembly to do what it would like to do, and that's get that moisture out of the assembly so that it does not degrade that over time. And we talk also, we're from Maine. I don't know if there's folks from outside the cold climates, but mostly we get into the discussion talking about heating, right? But it's also important to think about the fact that our insulation does a fabulous job mitigating the need to put on the cooling equipment, the HVC and such. So low thermal conductivity and heat capacity balance the temperature swings in conditioned space, reducing heating and cooling loads. And that's fantastic because I know here in the Northeast, we have one day we have winter and the next day it's 46 degrees. So the swings are pretty radical. So the wood fiber absorbs the heat slowly over time and radiates warmth out when the cooler conditions exist. I'm going to show you on the next slide a pretty interesting case study. So picture yourself, this is an attic condition, and we always like to use performance values, right? For the window industry, it might be a U value for the glass performance or a DP rating, or for anything related to insulation, it would be an R rating for resistance, and the higher the better, right? So here we're looking at XPS foam, which does have a higher R value per inch, and a mineral wool with an R4 slightly higher than the wood. So by all rights, if we're purely looking at that thought process of R value and the higher the better, well, that might work for the thermal situation, but it doesn't really reflect what's going on for heat gain. And so I'm going to hit a little button here and take a look at the thermometer here. And we do have a coupler in the bottom of this, so it's kind of now get charged with the sun coming up, summer day, and it's actually the opposite. In this particular case, that R value is irrelevant in terms of what it's telling you, because what it's going to show you is that the wood density is actually going to stave off the heat gain far better than the XPS, and certainly better than the mineral wools as well. So it can take that temperature gain into the product itself, and as the sun then starts to sunset off, it's going to release that back up into that attic space. So it's going to put a lot less demand on your cooling conditions. So it's just something we like to talk about. You see here in the lower left, you're on one of them. This is a Beyond the R value, and we do these every third Thursday of the month. And thank you for joining us today. So that's a little bit of our, what we call Mad Lab experiments that we have up here at the mill. And Addie did a fabulous job talking about the makeup of the products, opening the indoors. What we're talking about there again is that open assembly, and also the non-toxic aspects of the materials that we're using in our product really allow for good, healthy indoor conditions. When we go to market, the first thing we need to do is test for code, for AST, fire, bugs, water, R value, etc. I just want everybody on the call to realize and understand that there's another body of work that we will be doing for each individual product. As soon as it's completed and goes to market, we're starting to work on life cycle analysis, declare label, and the like. So we'll continue to work to put out future documents for future state for folks that are on this call that are very focused and needing to know about the indoor air quality. And I think you're going to like what you see when we finally publish that information. But one of the things that's fabulous about the Timber Fill and the bat is that it's just not thermal. We can deal with sound abatement, STC, sound transmission coefficient. That's near and dear to me. I spent a lot of time at hotels. I'm that guy that needs to be on the top floor, away from mechanicals and away from the highway. And so if there's folks here that do multifamily or hotels or senior living or high homes with lots of kids, I think you'll be happy to realize that wood fiber can also help us with the acoustic performance as well. And we do have, obviously, Timber Fill is blown into the demising wall, but for the bats, we do have some different dimensioning that allows us to go into demising walls, both for the non-load-bearing steel as well as wood. And so if it's single family and you're using wood, no problem. If you're designing a project where commodity prices are critical, you might sometimes use wood framing, but maybe that's run high and you've got to go steel. Either way, we have dimensioning for you. Now, steel is not necessarily the best performing. The STC rating here is at a 45. And that is with the condition. It's not just, as you all know, but it's really kind of a cake recipe, right? The bat in this case, or the Timber Fill, is just one component of that cake recipe. So when we test these products, we're testing them in an assembly. So you can see that recipe mix there with the assembly components, with the 5/8 gypsum, the 3 5/8 steel, and 16-inch on center, and the like. So very straightforward. But when you go to wood, we're going to get a little bit of better performance there. And these are just mock-up performance here. We're going to still continue to do more testing data, but it's really, really nice to see that with the fill in the bat, we are able to get up with a 2x4 wall up to an STC of 50 versus the Rockwell at 47. So we've had a lot of folks looking to use our product for decarbonization, sustainability, where maybe in the metro area, they can't use this in the exterior walls, but in the demising walls, they can. So there's a lot of flexibility there to think of beyond just the thermal components that we offer. And it's really fantastic. I mean, production is driven by your costs. And, for us, we have this plentiful wood supply up here in the forests of Maine. 90% of our raw material going into these three products that we've discussed are readily, easily available. We got a recycling grant funding for $85 million for green recycling. So we're in essence a recycling center. That's one tranche of our investment money came from that. That's underwritten by Citigroup. And it really helps us financially be sustainable and bring our products to the market in a cost competitive way. And then no toxins and no fibers, irritable fibers. I mean, you're literally just brushing the material off when you're working with it. We'll have a whole series of different tools to provide for you in terms of cutting. So when you're looking at the bat, when you're looking at the board, it's really quite easy to work with. The only thing from an SDS standpoint that we would recommend is a paper mask. And if you have sensitive eyes and such and you're blowing it in, you might wear a full face mask. It's really more for the uncomfortableness of some of the wood fiber when you're cutting. But other than that, it's more of a nuisance per se, in the sense that you just don't want to inhale it. There's nothing really problematic with any of the toxins and all, because there are none. It's just really trying to make it easy at the end of the day. Take your mask off, no harm, no foul. If you don't, then you're just gonna need to blow your nose a little bit to clear out, but that's about it. And you're brushing it off your body. So very, very easy to work with. We're obviously going to be code compliant. We're going to be focusing on the United States first and foremost. We will have pathways up into Canada for code compliance as well. So as soon as a particular product is done, or almost done, we're starting to do compliance testing by third party and going out and testing for the various different disciplines that we need to. So when you're looking at cellulose, we're testing to the ASTM 119 E84. Same with the bat, because as you heard from Addie, both of those products are interior to the building, and both of those products comply with the ASTM E84 flame spread A, and they both happen to have liquid borate infused into that product. And then of course on the board side, we have some different testing there that we need to do. In this particular case, we're coming in at an ASTM E84 flame spread B. So obviously those things are important to us in terms of where we fit into constructability. And we'll talk a little bit more about that as well. So we look at this, if you're looking at a wood framed assembly foundation up, we're really, particularly for anything that's wood framed, and that could be type 3, 4 stories or less, light commercial, multifamily, CLT construction type 4 and or type 5. It's a very straightforward drop-in replaceable, and it really allows you to then now consider wood fiber as an alternative to what's out in the market today, which are some of the foams that people are spraying, or the mineral wool, cellulose, as we've mentioned, and then fiberglass. So it's really fairly straightforward, and the price points, depending on what you're looking at, are kind of nice too, because as we've discussed, we're at parity with cellulose, and we know that because we've been in the market. So we're seeing capitalism do its thing. The board product line is coming up and running right now, so we'll see where that fits, but that should be very comparable, or a scant bit lower than the mineral wools. And then, again, reiterating this above grade piece, we just want to make sure that people are following what you would typically follow for traditional American panel associations in terms of compliance with the exterior enclosed assembly. Here's some pictures that show you a little bit more granular. You can see Den's pack being utilized in that upper photo, and to the right is a deep retro on a farmhouse up here in Maine. They're going to tear out the windows and then put in, I think this was a 5.5-inch board, and and knowing that many of you are quite interested as to when the board is, that was from Europe, that was imported. So we'll stick to the timeframes that we've discussed, but we've always been doing a lot of testing ourselves prior to having our own products come online. Same with the College of Atlantic lower left. That's really just showing you the fact that we can get into those light commercial buildings. We can get into that multifamily. That's new construction, and that's all wood framed. You can see the zip sienna red sheathing in the foreground there, and that's Gutex that they used. We see a huge opportunity for system build as well as panelization. So off-site manufacturing, we're doing a lot of work with some folks that do that, and absolutely we see some opportunities to partner with some of those folks. And of course, what's been fun is going out and talking to the folks that have been using these products from Europe for some time, and that is the Passive House, Net Zero, and a whole host of other associations. So Passive House, FetusCon, if you will, a lot of folks that are really super excited that we're doing it domestically in the United States, because now we can bring down that price point for them, and we can work with our distributor and our dealers to have it readily available so that it mitigates any concern for their production schedule. I'm going to take a quick look at the time. Oh, I turned my clock off. Addie, can you tell me what time we have?
You've got about 10 minutes, Scott.
Great, thank you. I shut my phone off just to not be distracted by it, and that did me a disservice just then. So embodied carbon, really, really an important topic, not for all, but we're finding that there's a tremendous interest in this discussion. So we'll talk about it here on our call today. So insulation products made from wood fiber are superior, climate-friendly alternative to the conventional insulation. The opening slide of this presentation talked about carbon sequestration. No different than what you're using for your 2x4s, your sheathing, etc. I mean, you're literally using wood products, and that fiber, that material is being sequestered into that material. So now TimberHP can introduce this into the insulation category for where it fits, right? We don't fit in every single category. We really don't see too much of a fit, a little bit with the sound abatement perhaps, but type 1, type 2 in the inner cities, exterior walls with non-combustible pieces, probably not our strong suit, but in the type 3, 4, and 5, way to go. I mean, that's a perfect spot for us. 90% of the wood that we're sourcing today, and Addie's doing a lot of work around this as well for some different pieces of work that we're still trying to flush out, but 90% of what we're using is Forest Steward Council softwood chips, all from Maine. So all of this material is coming from Maine, and with the paper mills shutting down, sadly, it makes it so much readily more available for us. We're using the exact same feedstock, the exact same wood chips that this paper mill used to make high glossy flat paper up until 2016. So it's kind of really pretty interesting. On the right, what you're looking at is kind of future state, right? In theory, depending where we go in the next manufacturing facilities, we can actually take, as you can see, waste from production job sites, end cuts, if you will, and introduce it into our feedstock. Moving out, 15, 20, 30 years ago, from now, we could actually take back the various different products that are in the market, recycle those back into a viable product as well. And this is just basically third grade science or middle school science, if you will. We're having the photosynthesis occur. We're storing that carbon in the tree. If it was to decay out in the woods, slowly it would off-gas the carbon. But we can then take that and either make it into a paper product, a wood product, could be burned off in biomass, but then we're going to release the carbon. Or here, what we're doing up in Madison, Maine, is we're taking that product and we're sequestering it into our wood fiber product. This is a big one right here. A lot of people will ask us, why don't you put this up front? Well, we always say that we speak to a lot of different groups. A lot of folks are interested in the wood fiber because maybe it's specified that way and they're needing to procure it because somebody's wanting to use it. They may not pick that as their first go-to market because it represents change. But many people are looking at wood fiber because it's the first domestically made insulation here in the United States that's actually coming in at a negative kilogram. Whereas most of these products, as you see, there's quite a bit of carbon being released. And if you look at spray foam and XPS, you're looking at about a 6 to 8 year offset in terms of that building being up and running to offset the embodied carbon that it took to make that widget, if you will. Product's great R value, durable, can get installed. Fantastic. It's reducing that consumption of heat and cooling cost over the years. But how much energy was necessary to make that product in the first hand? So if we can do both, give that super high R value to make sure that house has what it needs for code compliance and or above, and we can bring in a widget that we're making where we're sequestering that carbon and bringing it in at a negative because we're sequestering the material. That's why we're at a negative number. That's a big game changer, and people are loving it and the design communities for that reason. And there's a lot of consumers that are certainly very interested in this discussion as well. Now, a couple slides just to end the presentation. We're just showing you how this factors out as we talk about the kilograms of carbon when you're using wood fiber being mitigated in terms of use. So we're looking at a traditional wall section, and now my slides aren't advancing. Hodges, sorry. I don't know if you can step in. There we go. So we're looking at a 2x6 bat in this particular case. It's a 1,500 square foot passive house, so it's an extremely tight home. And if you were to look at the different materials, such as fiberglass or mineral wool, you can start to take a look at how much offset or carbon is being released into the atmosphere with this particular assembly, whereas with the wood fiber, you're at a net negative. And a lot of people look at this and go, okay, I know I want to really have a nice sustainable building that I'm building, but I also want to track carbon, and I want to try to reduce as much carbon in that building as possible. There's some things that we put into our buildings that you just can't address. I mean, it is what it is, and you can't do it. So some folks are now looking at wood fiber going, all right, hooray, I've got another area here with insulation that I can use to help me with my decarbonization piece. So there's a lot of folks that are super excited about that, and that it's here in the US as well. So now what we're looking here on the right is that we are going to an outside continuous insulation 5.5-inch board, and that's going to obviously 1 + 1 is 2, is give us even more savings in terms of the sequestration of the wood fiber and less carbon being released. In fact, you're at a negative. So if you're counting carbon on a building during design and such, you're actually able to subtract off that count. And when we're looking at that, I mean, if you're looking at a 2x6, you're at a 5.5-inch bat, that's a 22 R value. When you're looking at that 5.5-inch board, that's an R20, just to give you some perspective when we look at that detail. So the CO2 savings, another way to look at it for this particular assembly is reducing, an equivalent to the emissions from driving 23,500 miles. That's just another way to look at that savings. So now if you look at that, I've got so many different screens open here. I'm sorry, I've got a rat's nest that I'm looking at. So if you look at the total CO2 savings for one house, it's equivalent to the emissions from driving one car for 2.5 years. So if you're looking at that totality of that house and you're using that assembly, you're looking at 24,750 kilograms of CO2 not being released into that environment. So pretty impressive. And if you extrapolate that out into a multifamily project and such, a really nice net gain for us here for team environment. Yeah, so if you can advance that, Hodge, I don't know what I've done, but I'm capable of doing it. My slide's not advancing.
I do not have the power to advance your slide, but I can confirm that this is the end of our slide deck presentation. So I'm going to go ahead and wrap things up for us. That was a lot of information. We had some really interesting questions happening in both the chat and the Q&A. If there are any outstanding questions for folks out there, you can absolutely always contact us at info@timberhp.com. We also went ahead and threw in some links into the chat with our video library, our technical library, and our frequently asked questions pages. Those are really great landing spots if you wanted to take some time this afternoon or over the holiday break to do a deeper dive. That's a really great resource that you all have access to. I realized that at the beginning of the webinar, I did not give a proper tee up for our 2024 series. So as we mentioned, this is our Beyond Our Value continuing education series. Every third Thursday of the month, we host these. And going into 2024, we're going to switch it up a bit. Quarterly, we're going to host roundtable discussions with some well-known folks in the industry yet to be released, but stay tuned on our social pages for the announcements on who exactly will be on our roundtable discussions, but we're really looking forward to that. And of course, we're going to continue with our deep dives into wood fiber, specifically looking at our 3 products as they come on the market in the first quarter of 2024. Scott and Addie, anything you wanted to add before we say goodbye to everybody who's been with us for the last hour? Thanks everybody for the time today.
Addie?
No, thanks for joining us.
Please, we gave you our cell phone numbers and emails. We're absolutely available to help you out with any questions you have. Thanks for your time and have a great holiday.
Yeah, thanks everybody. We'll look forward to seeing you in 2024. Bye.